Hey Chem students, this is Mrs. Miller. I'm just making this quick supplementary video to help you guys solve titration problems if you are not here because of AP testing. So there's going to be 3 different methods that we can use. All are going to solve our titration problems the same way, well, different ways, but come up with the same answer. Alright, so you guys may have seen this in the notes, the steps involved in determining unknown concentrations. So this is kind of the long form of figuring out titration equations, but you can use it absolutely. The same thing is going to be every version that you use, you always need a balanced chemical equation. So you always need to write out the balanced chemical equation, and then this would be for the first method that we're going to use. So you would use the molarity relationship, and if you remember, the molarity relationship is molarity is equal to moles over liters. And that'll allow you guys to figure out the number of moles, the standard used. Then use the mole ratio, remember that's from the balanced chemical equation, to determine the number of moles of unknown used to completely react with the standard. And then last, calculate the unknown quantity, again using that molarity equation. So I want to show you guys the longest method, or the first method technically, of how you could solve a problem like this. Alright everyone, so this is the example from the first one on your worksheet. So in a titration of 35 milliliters of drain cleaner containing NaOH and 50 milliliters of 0.4 molar HCl must be added to reach the equivalence point. What is the molarity of the base in the cleaner? Okay, so we know that we're going to be reacting NaOH with HCl, so the first thing that we have to do is we need to come up with a balanced chemical equation. So one of our reactants is going to be NaOH, the other reactant is going to be HCl, and then we're going to go through a double displacement reaction where sodium is now going to be dancing with chlorine, OH is now going to be dancing with H, and we would also be able to fill in the amounts that we know. So I'm going to just take a quick look at that, and step 1, when I end up doing it properly, is NaOH plus HCl yields NaCl plus H2O. I also know the molarity and the amount of substance that I'm using for hydrochloric acid. So I have 0.4 molar, and I have 50 milliliters. Really, this should say 0.050 liters. Let's see if I can kind of get rid of that. Liters. This should also say liters because I already converted that. Remember, if you don't remember how to go from milliliters to liters, you simply divide by 1,000. So then I have my 35 milliliters of drain cleaner that has NaOH. So 0.035 moles, okay? So step 2 is then to go from using the molarity equation from molarity in liters, and I should be able to calculate out how many moles of HCl did I use here. So let's go ahead and take a look at that. The molarity equation, remember, is moles divided by liters. I have the molarity, 0.4 molar. I do not have moles, I'm looking for that, and my liters are 0.050. So I'm going to go ahead and plug that in, and I would take and rearrange this so you end up with moles times liters equals, molarity times liters equals moles. So 0.4 times 0.050 is equal to 0.020 moles. So that's how many moles of HCl I used. After I know how many moles of this I used, I should be able to use a mole ratio to go into NaOH. So when I go ahead and I do that, I have to look at my balanced chemical equation. I have this many moles of HCl, and according to my balanced chemical equation, it's 1 to 1. So 1 mole of HCl is equal to 1 mole of NaOH. So I still have 0.020 moles, but now I went from moles of HCl into moles of NaOH. Last then, I want to go from moles of NaOH. I can use the liters that I have and figure out the molarity. So when I go ahead and I do that as well, I know that I have 0.020 moles. I know that I have 0.35 liters. So what I'm going to go ahead and do is I'm going to take moles divided by liters, 0.020, divided by 0.035, and I end up with 0.57 moles of NaOH. So that would easily solve this problem. I have to go through 4 steps, which is fine. Here's the reason I don't love this method. Because you go through 3 separate calculations, there is a big chance that you guys are going to do some sort of issue with rounding or with sig figs. So instead, I want to show you a second method where you can eliminate all of these little calculations by themselves and have it as one giant calculation. So here's the exact same question, and I'm going to go ahead and just answer it in a slightly different way that uses one long t-table or one stoic problem instead of 3 separate problems. So we still have the titration of 35 milliliters of liquid drain cleaner containing NaOH, 50 milliliters of 0.40 molar HCl must be added to reach the equivalence point. What is the molarity of the base in the cleaner? So I still am starting off with my balanced chemical equation. Same thing. Still identifying how much stuff I have used. This time, when I go ahead and start, what I'm going to start with is the amount of the known substance that I'm starting with. So, amount of the known used. So, 0.050 liters. What I'm going to do then is if I know I have liters of that and I have molarity of the NaOH, remember, molarity is literally moles per liter. So I can use that label to go ahead and calculate into moles. So what I'm going to do is use that molarity, and I am going to break it up like this. 0.04 moles of NaOH is equal to 1 liter of NaOH, because that's literally what the molarity means. And when I do that, my liters end up canceling, and now I'm in moles of NaOH. Now that I'm in moles of NaOH, I can easily convert into moles of HCl simply using the mole ratio. So I have 1 mole of NaOH on the bottom, so it cancels out these moles of NaOH, and that's equal to 1 mole of HCl. And then what I want to do, molarity again, is moles divided by liters. Currently I have moles of HCl. I also know how many liters of HCl I used. So I'm just going to go ahead and put the 0.035 liters on the bottom. So notice that these two don't cancel, so I'm left with literally moles divided by liters, and that is going to give me my 0.57 molar or mole per liter solution of HCl. So this is the exact same problem as what you saw in the previous slide, but instead of breaking up into 3 different steps, it's broken up into one stoic problem, less chance for rounding errors, and less chance for sig fig errors. So that's the second option. The third and final option that will work in certain methods is going to be the shortcut method. So the shortcut method is what we see here, MAVA equals MBVB. The big key here, though, is the fact that the ratio has to be 1-for-1 for this little shortcut to work out. If the ratio is not 1-to-1, you can't use this. So MA literally means the molarity of the acid, VA, the volume of the acid, MB, the molarity of the base, VB, the volume of the base. So we know that we have 35 milliliters, or 0.035 liters of NaOH, so that's the volume of the base. We know that we have 50 milliliters of the acid, or 0.050 liters. We know that we have 0.4 molar HCl. So go ahead and plug this in. MA times VA equals MB is what we're looking for, times VB. Rearrange this calculation, and X is still equal to 0.57 molar. So again, this only works when your mole ratio is 1-to-1, so you have to have a balanced chemical equation that your coefficients are 1 and 1. Otherwise, you have to use one of those other methods. But all 3 of these are going to get you to the same answer. If you have any questions, let me know. Otherwise, have a great day.